Okay, so I just wanted to do one hyperbola and graph the whole thing out, and then look at one problem and solve it algebraically, just so you guys can kind of see everything you're going to be doing for your homework and stuff like that. And keep in mind, much like with ellipses, we generally start with our ellipse, hyperbola, parabola, whatever centered at the origin. Much like with an ellipse, you can easily move them around. It really just makes it maybe a little bit harder to correctly find your A and B values. But you understand the principle. So this one, we're just going to have it centered at the origin. But if I just did x plus 2 squared and y minus 3 squared, it would be the same thing. It would just shift it around. So just for the purposes of this, we're going to keep one centered at the origin. So suppose we have this. X squared over 16 minus y squared over 9 equals 1. So we want to graph it all out. First off, let's see. We have to figure out the orientation. In this case, this is first and it's bigger. So that's a squared, that's b squared. And since the x is first, it's oriented horizontally. We then get that if a squared is 16, a equals 4, b equals 3. Right away, just to kind of get as much information as possible, we mentioned at the end of the last video, for this one we actually have the Pythagorean theorem identity relationship. So we get a squared plus b squared equals c squared. So 16 plus 9 equals c squared, which means c is equal to 5. Now I have that. Now I can actually start filling in some details on my graph. Let's see. A is 4, and it's horizontal. So I'll go out to the point 4, 0. And out to the point negative 4, 0. Let's see if I can keep this relatively the same. B then will be vertical. It's at the point 0, 3. And 0, negative 3. And then C is 5, that's the distance to the foci. If this is 4, then we'll say the foci 5, 0 is right here. And negative 5, 0 right there. And now we know, just by looking at it, I'm going to go through the vertices towards the focus. So my graph will look like this and look like this. But we want to make it as accurate as possible. So what we do is, pick a different color, essentially draw a box right here. And again, the box may not be perfect because I don't draw well, but all we really care about is the corners. This corner is the point negative 4, 3. This is the point 4, 3. This is the point 4, negative 3. And this is the point negative 4, negative 3. From there, I can then draw a diagonal line through the corners of the box that goes through the center of my graph, the origin. So I draw this line and this line. Like I said last time, keep in mind, these are not actually part of your graph. These are just guides to help us graph it. It's not entirely straight, but it's pretty close. Now, if you want, you can find the equations of those lines, those two axes right there, asymptotes. If you want to do it just to do one, we'll do this one right here. You have the point negative 4, 3 and 4, 3, so find the slope. Change in y. 3 minus minus 3 is 6, over 4 minus minus 4 is 8. So your slope is 3/4. So you get y equals 3/4 x plus b. But for that line, you're actually going through the origin. So b, the intercept, is just 0. So there's a line right there. Y equals 3/4 x. And then if you did the same thing for this one, let's see. Change in y. 3 minus minus 3 is 6. All over minus 4 is minus 8. And you get negative 3/4. So we get the line y equals negative 3/4 x. And there we go. Those are the equations of those two lines which we can find. But now we have all the information we need to graph it. So all I do is, let's see, we'll do it in pink right here. I start at the vertex, And then I curve towards the asymptotes that I just drew. So it goes like that and like that. Start here, curve there, and curve there. And now there's my graph. And again, I just stress one more time, yes, there's a lot of stuff all over this picture. The actual graph, the hyperbola that we care about, is just the stuff in pink right here. The rest of that is just properties that help us figure out what the graph looks like. Okay, good. Now, I just want to algebraically go through a hyperbola, because now, since we have ellipses and we have hyperbolas, ultimately when I give you equations on your exam or whatever, I'm not going to give you an equation like we just had, where your equation says x squared over 9 plus y squared over 25 equals 1. What is that? Oh, that's an ellipse because it's a sum. That's too easy. So generally what we're going to do is I'm going to give you an equation in general form, like we did with an ellipse, and then you're just going to have to do the algebra to figure out what type of conic section it is. So I want to make sure again that we can actually do the algebra. So suppose we have this one, negative 7x squared plus 16y squared minus 70x plus 96y minus 143 equals 0. Well, good. Figure out what type of conic section that is. It's going to be a hyperbola, because that's what we're working on. But assuming you didn't know that, say it's on the exam, do the algebra to actually figure out what conic section it is. We said last time, there's kind of a standard approach to this. Complete the square. So first, isolate the x's and the y's. So we'll rearrange this and get negative 7x squared minus 70x plus 16y squared plus 96y. Add the 43 to the other side equals 143. Now let's see, in order to complete the square, the leading coefficient has to be 1. So factor out a negative 7, and you get negative 7x squared plus 10x, plus factor out a 16, and you get y squared plus 96 divided by 16 is 6y, equals 143. Well, now let's see. We have negative 7x squared plus 10x to complete the square. Half of 10 is 5, square that, you get 25, so add it on. For the next one, half of 6y is 3, square that, you get 9, so add it on. Now on this side, well, let's see, we have to be careful to keep things equal. Here, I didn't actually add 25. Remember, we have to multiply by the outside. Negative 7 times 25 is negative 175, which means actually I subtracted 175. Here, 16 times 9. 16 times 9 is 144, and that's added, so I add 144. Now, over here, we get negative 7, x squared plus 10x plus 25 becomes x plus 5 squared, plus 16, let's see, that will be y plus 3 squared, equals, and now solve this out. Let's see, 144 plus 143 is 287 minus 175. That's 112. And now, more like, it looks like it's going in the right direction towards turning into a hyperbola. What do we do from here? Well, we said last time, this has to be a 1 for it to be a hyperbola. So divide it by 112. So divide this by 112, divide this by 112, and this by 112. Then you get, let's see, negative 7 divided by 112 is negative x plus 5 over 16. Plus, here we get y plus 3 squared. 16 divided by 112, that's, should be 7. Yes. Equals 1. Now that's the equation of a hyperbola. The problem is, well, that doesn't really look like the form we have in your book, but the book always just puts the positive term first, so we can just rearrange this. Y plus 3 squared over 7 minus x plus 5 squared, I dropped my square right there, over 16 equals 1. Now we have my hyperbola in the nice form that I like. Just really quickly, to kind of finish this up, identify everything. It's oriented vertically, because the y is first, it's positive. And then let's see. A is equal to the square root of 7. B is equal to 4. C will then be equal to, let's see, Pythagorean identity. C squared equals A squared, which is 7, plus B squared is 16. So C squared is 23, which means C equals the square root of 23. So now I have my A, my B, and my C. I could plot all of that out, and I'm good to go. One other thing I would point out as far as this goes, when we had our ellipses, the A always told us the major arc and the B was the minor arc, and it was always the bigger one. The major arc was the bigger one, we called that A, the minor arc was the smaller one, we called that B, and we oriented everything that way. Here, since this is the difference, we care more about the positive one being first. In this case, that's negative, this is positive, so we put the y first, which tells me it's oriented vertically. But the A doesn't actually have to be bigger than the B here. This is just A squared and B squared. When you graph them, you don't have to have the rectangle that you will get when you plot out these points. It can be oriented in lots of different ways. It can be really tall and thin, it can be short and fat, it can be almost a square. So that doesn't necessarily matter. As far as it goes, I'm going to stop right there. You should have everything you need in order to solve all the problems in your book and on ALEKS. If you have any questions, let me know, email me, stop and see me in my office, whatever, and we will continue with this after break. I hope you all have a good Thanksgiving.